2.3 Derivatives of Natural Logarithmic Functions. Southwestern College, Professor Maria Olivas. Section 2.3 on derivatives of natural logarithmic functions. Our objectives for this section are going to be the following. First, we're going to differentiate functions involving natural logarithms. And second, we're going to solve applied problems involving natural logarithmic functions and their derivatives. So before we can start this section, we actually need to know what the derivative of the natural log of x is. So we're going to have to start off by deriving that. So we're going to begin with the derivative of the natural logarithmic function and its derivation. To find the derivative of f of x equals the natural log of x, we first have to start off with that equation. So I'm going to go ahead and write down y equals the natural log of x, or y equals ln of x. Now remember what this means. This means the same thing as y equals log base e of x. And it might be easier to write it this way when we rewrite this in exponential form. So here I'm also going to write that we need to find dy dx. And now I'm going to go ahead and start the derivation. I'm going to write out the equation y equals log base e of x. I'm going to draw a circle on the base e, and then I'm going to go ahead and draw an arrow pointing towards the y, and then another arrow from the y to the x. So it looks like it's going circularly here, clockwise. And then an arrow to the side saying e is raised to the y power is going to be equal to x. So that's what those arrows help me remember. Now I'm going to take the derivative with respect to x of both sides of this equation. I'm going to take the derivative with respect to x of e raised to the y power, and I'm going to take the derivative with respect to x of x. Now if I take the derivative of e raised to the y with respect to x, that's going to be e raised to the y times dy dx. And on the right hand side of the equal sign, the derivative with respect to x of x is just going to be equal to 1. I'm going to draw an arrow here pointing from this equation up to the upper right hand side of the screen, and I'm going to rewrite my equation e raised to the y power times dy dx going to be equal to 1. I need to solve for dy dx, so I'm going to divide both sides of the equation by e raised to the y power. This is going to cancel out the e to the y's on the left hand side, or they're going to divide out and equal 1. And we will have dy dx is equal to 1 over e raised to the y power. And this, remember, e raised to the y power, I'm highlighting the e to the y in yellow, and I'm also highlighting the e raised to the y in that first equation where I wrote e raised to the y equals x in yellow in the upper left hand corner. And I'm going to highlight the x in that same equation in green. Now I'm going to rewrite over here on the right hand side that 1 over e raised to the y is equal to 1 over x. And I'm just substituting x for e raised to the y. Now this allows us to write down the formula for the derivative of the natural logarithmic function. The derivative with respect to x of the natural log of x is going to be equal to 1 over x. And we're going to go ahead and box that in. I'm also going to write down that the derivative with respect to x of the natural log of u is going to be equal to 1 over u times du, and we're going to go ahead and box that formula in as well. Now that we have the derivatives for our natural logarithmic functions, we're going to go ahead and move on to some examples. Example 1. Find the derivative of each function. So for a, we have y equals -12 times the natural log of x. 2, find the derivative of this. I'm going to write here dy dx is going to be equal to -12 times 1 over x, because the derivative of natural log of x is 1 over x. So dy dx equals -12 over x. And we're going to go ahead and box that in, and that's going to be our answer for that problem. Now I'm just going to go ahead and lasso the work I did here for the example 1a, and I'm going to shrink it and make it a little smaller and move it upwards a little bit so it's not taking up too much space. Let's go on to example 1b. G of t equals natural log of, open up a set of parentheses, 3t minus 1, close the parentheses. So g prime of t would be equal to 1 over 3t minus 1 times the derivative of the inner function, which in this case is going to be 3. We have to still apply the chain rule here. So g prime of t is equal to 3 over 3t minus 1. And we're going to box that in as our answer. All right, let's move on to example 1c. F of x equals e raised to the 2x power times the natural log of 4x. Here we're going to have to apply the product rule. So that's going to be u dv plus v du. I'm going to label here as the e raised to the 2x as our u and the natural log of 4x as our v. So let's go ahead and start writing this out. F prime of x is going to be equal to e raised to the 2x power times dv, which in this case will be 1 over 4x times 4 over 1, plus v is going to be natural log of 4x times du, and du is going to be the derivative of e raised to the 2x, which is e raised to the 2x times 2. Now let's simplify this out. F prime of x equals, here the 4's are going to cancel out or divide out and give us 1. So we will have e raised to the 2x over x plus, over here, we can definitely move that 2e raised to the 2x up to the front. So it'll be 2e raised to the 2x times the natural log of 4x. And we can now box that in. And that's going to be our answer. So after I go ahead and box in that answer for example 1c, I'm going to lasso in the work that I did right above the box that I just drew for example 1c, and I'm going to shrink it horizontally just so that I have a little bit more space here for example 1d. I'm also going to draw a line coming down from the very top in the middle here from example 1, right after it says find the derivative for each function, all the way down below example 1c, and I'm going to extend this line over horizontally to the left. And it's just so that I can have a line dividing the work here so that the work is separated between my examples. I'm also going to lasso the work I did for example 1b, and I'm going to move it slightly to the right so it looks a little more centered in that area. So for example 1d, we have y equals the natural log of x, where the entire natural log of x is being raised to the 7th power, versus y equals natural log of, open up a set of parentheses, x raised to the 7th power, close the parentheses. I'm going to call each one of these a separate letter, so I'm going to call this first one a and the second one b. So for a, or part a here, we have y equals natural log of x, and the entire natural log of x is being raised to the 7th power, where the 7th power is written in between the natural log and the x. I'm going to rewrite it as y equals, open up a set of parentheses, natural log of x, close the parentheses, and then raise to the 7th power. So it's a little more clearer as to what we're working with here. I'm drawing an arrow pointing down towards this problem, towards the equation I just wrote down, and I'm going to write here, open up a set of square brackets, u, close the set of square brackets, raise to the 7th power. We're going to call the natural log of x u. So now here we're going to have y prime is equal to 7 times, open up a set of parentheses, natural log of x, close the set of parentheses, raised to the 6th power times, this is going to be the derivative of the inner function, which is the natural log of x, so that's going to be times 1 over x. So y prime is going to be equal to 7 times the natural log of, I'm going to write the 6th power right between the natural log and the x. So it actually means the natural log of x, the entire natural log of x being raised to the 6th power all over x. And I'm going to box that answer in. And I'm going to make my little u substitution that I showed up here. And I'm going to lasso that and I'm going to shrink it just so it doesn't take up so much space. Part B. Y equals natural log of, open up a set of parentheses, x raised to the 7th power, close the parentheses. So this is a different problem here because not the entire natural log is being raised to the 7th power, just the x. So this is going to be y equals 7 times the natural log of x, and we're using that power rule for logarithms here. Y prime is going to be equal to 7 times 1 over x. So y prime will be equal to 7 over x. And that will be the derivative for that problem. So that way you can see the difference between these two problems. Even though they look very similar, they have very different derivatives. I'm going to draw a line in between the part A and part B for this example so that you can separate the work here so it's not, doesn't look like one entire problem. It kind of looks like two separate problems here. Okay, we're ready to move on to our next example. Example E. H of y equals the natural log of, we're going to open up a set of parentheses, y squared plus 3, all in the numerator, and it's going to be all over 4y plus 1, and then we're going to close the parentheses. So for this logarithm, we are going to use the rule, the log of a quotient is the difference of the logs. So I'm going to rewrite this as h of y equals the natural log of, open up a set of parentheses, y squared plus 3, close the parentheses, minus the natural log of, open up a set of parentheses, 4y plus 1, close the parentheses. So there is a page number at the bottom of this screen here. It says 5. I'm just going to erase it so that it doesn't interrupt with the work that I'm going to be writing down. So h prime of y is going to be equal to, here we're going to have 1 over y squared plus 3 times 2y over 1 minus 1 over 4y plus 1 times 4 over 1. And we are using the chain rule here. H prime of y will be equal to 2y over y squared plus 3 minus 4 over 4y plus 1. And we're going to go ahead and box that in, and that's going to be our answer for that problem. Example 2. Find the equation of the line tangent to the curve f of x equals the natural log of, open up a set of parentheses, ex, close the parentheses, all over x, when x is equal to 1. So the first thing we need here is you need a point, and we're also going to need the slope. So you need a point and the slope. Let's find the slope first. To find the slope, we're going to write down our equation f of x equals the natural log of, open up a set of parentheses, ex, close the parentheses, all over x. We're going to have to find the derivative of this. So I'm pointing an arrow at this equation and I'm writing down the words quotient rule because we're going to have to use the quotient rule to find this derivative. The quotient rule says v du minus u dv all over v squared. So our numerator represents our u, our denominator represents our v, and all we have to do is just follow this rule. F prime of x is going to be equal to x times 1 over ex times e over 1. We're going to subtract from that, open up a set of parentheses, natural log of ex, and then we're going to multiply that with a 1. And this is going to all represent our numerator. It's going to be all over our v squared. and our v squared is just going to be x squared. F prime of x is going to be equal to, here I'm simplifying, I'm canceling out the e's, and that I can divide those out, so I'll be left with x over x, which is just going to be a 1, minus the natural log of, open up a set of parentheses, ex, close the parentheses, all over x squared. F prime of x is going to be equal to 1 minus the natural log of ex all over x squared. So this equation represents the derivative of our function, and it will allow us to find the slope at a specified value of x. And since they told us when x equals 1, we can substitute that 1 into this equation. I'm going to go ahead and lasso all the work I did here for the slope, and I'm going to shrink it a little bit, and I've also gone ahead and drawn a line to divide this basically into a left and a right hand side here. I'm going to go ahead and find f prime of 1, which is equal to 1 minus the natural log of e times 1 over 1 squared, which is equal to 1 minus the natural log of e over 1, which is 1 minus 1 over 1, which is equal to 0 over 1, which is equal to 0. I'm going to lasso that whole line of work that I just did there, and I'm just going to shrink it horizontally so it fits on the left-hand side of my line that I drew here to separate my work. On the right-hand side, I'm going to write point, because now I'm going to find the point where x is equal to 1. So I'm going to find f of x equals, well, I'm going to write my equation first down. F of x equals natural log of ex over x. And then f of 1 is equal to the natural log of e times 1 over 1. And this is going to be equal to natural log of e over 1, which is just the natural log of e. So my point here is going to be f of 1 equals 1 over 1, which equals 1. And I'm going to draw an arrow pointing towards the point. So my point is going to be 1, comma 1. Those are my two steps. I kind of labeled the slope part as part 1, the point is part 2, and then part 3, I'm writing out point slope form. I'm going to use point slope form to come up with the equation. Y minus y sub 1 equals m times the quantity x minus x sub 1. My x sub 1 is going to be 1, my y sub 1 is going to be 1. So 1 minus 1 equals 0 times the quantity x minus 1. Then we're going to end up with y minus 1 equals 0, and we're going to add 1 to both sides to isolate y, and we will have y equals 1. Y equals 1, we're going to box that in because that represents our equation of the line tangent to the curve f of x when x is equal to 1. It also happens to be a horizontal line, so that's why I'm writing down the word horizontal line inside parentheses next to it, so you can better visualize what this would look like on a graph. Example 3. In a study about learning, students were given an exam and then retested monthly for 6 months with an equivalent exam to see how much information they retained. The equation below relates the time t in months after the initial exam to the average score S that students earned on the exam. S of t equals 84.6 minus 11 natural log t. A. Evaluate S of 2 and S of 6 and state what these values represent. So here we're going to be asked to evaluate S of 2 and S of 6. Let's start off by evaluating S of 2. S of 2 is going to basically represent the average score 2 months after the students have taken their initial exam. So let's go ahead and find that score first. S of 2 is going to be equal to 84.6 minus 11 times the natural log of 2. S of 2 is going to be approximately equal to 77.0. Now let's go ahead and find S of 6. Let me draw a line here to separate the work from the S of 2 portion. S of 6 is going to equal 84.6 minus 11 times the natural log of 6. So S of 6 is going to be approximately equal to 64.8. So let's go ahead and we need to box these answers in, and we also need to state what each of these values represents. I'm underlining the key part here. that we need for stating what these values represent. The time t in months after the initial exam to the average score S that students earned on the exam. I'm also going to box these answers in. And so let's go ahead and write this in. This, for S of 2, this is going to represent the average score after 2 months. So 77 would have been the average score after 2 months from the initial exam for those students. And S of 6, which was approximately equal to 64.8, is the average score after 6 months from the initial exam that the students took. Let's go ahead and box in those explanations of what the values represent. Part B, evaluate S prime of 2 and S prime of 6. Explain what these values represent and what trend you observe in the data. Well, first we need to find S prime. So let me write down S of t, which is equal to 84.6 minus 11 times a natural log of t. S prime of t is going to be equal to negative 11 times 1 over t, which is going to equal negative 11 over t. Now we can evaluate S prime of 2. S prime of 2 is going to be equal to negative 11 over 2. And this can be also rewritten as negative 5.5. And this represents negative 5.5 points per month. So based off of this negative value, I can tell that the average scores are going to be decreasing at a rate of 5.5 points per month after 2 months from the initial exam. S prime of 6 equals negative 11 divided by 6, which equals negative 1.83 with a repeating bar over the 3 points per month. So this negative value here represents that the average scores for the exam will be decreasing at a rate of 1.83 with a repeating bar over the 3 points per month, 6 months after the initial exam. So let's go ahead and write down in words what this represents. These values represent the rate at which students' scores are changing. In this particular case, they're decreasing. So I'm going to write down in parentheses here that the scores are decreasing. So let's go ahead and box in our answers here. I'm going to box in the values we received here when we evaluated S prime of 2 and S prime of 6. And I'm also going to put a box around our explanation. And that's going to be our answer for this problem.